Howdy, Huskies. Welcome to day 5. This is the wrap-up day and making sure we are all good. Really, this is a review, so if you're watching this, that means you have watched 1 through 4, and you feel like you've mastered 1 through 4. I'm just going to sort of bring us home, talk about things from maybe a different perspective, reiterate some key concepts and things like that. You guys should make sure you're good on everything beforehand. So I'm really going to go ahead and try to value your time, and this is going to be a long video as it is, so I'm not going to go ahead and do the review questions to start, but what I am going to start with is just a basis for what you should be doing when you're solving equations. And it really comes down to, do you have just a single x, or do you have a 2x and a 3x and an x over 2? And so we'll start with the latter here just for a second. If you have one of these, again, it really is over those identities, making sure you're ready to plug those in, that you're thinking about them, and plugging in the one that makes the most sense. And then the second thing is obviously that delta substitution for the 2x, the 3x, etc., or I should say the x over 2, etc., making sure you're good with there. Now, what we're going to spend the most of the time for today on, in fact, almost all of it, is the single x, and that's what we spent almost the entire 4 days on. So a couple of things that I would do to make your lives easier, or where to start. And the first thing you always want to do is basically assume that you're going to be doing some sort of factoring, okay, unless it's really all set up for you. So you're looking for either a GCF. Now, if it's a trinomial, that's 3 terms, then you're going to do that x that we all like to do for factoring, or it's going to be some sort of perfect square. So generally, if we want to go ahead and elaborate a little bit further, this is usually when it's 3 terms, and the other 2 are going to be, obviously, perfect squares are going to be 2 terms, and GCF could be any of the above. Now, substitution. The reason why I bring in substitution is we already talked about the delta substitution in the previous videos. G did a great job on those. Watch that again if you have issues. It also could sometimes go ahead and give you some direction on where to go. So sometimes when we have cotangent and tangent and all this other stuff, go ahead and just basically call a U substitution a trig x. And I call it trig x as saying that could be a sine x or a cosine x. So something over here, if I make this, it's a cotangent squared, I can make this u squared is equal to u. And sometimes that frees up your mind to go ahead and say, I can solve this. And then just obviously remember that you always need a back substitute like you would do with the delta. Back to basics, and I think that is an important one too. In that, remember, when I say back to basics, that means that you're going to use sine, cosine, and tangent. If you have cosecant, if you have cotangent, assume that at some point you're probably going to change that and make your life a little bit easier, okay? And then last but not least is the most forgotten part is the picture. And that's going to say, does your answer make sense? And I think that that's the most important part. Does your answer make sense? A lot of you guys are going to want to just do your trig function, solve, and move on. You're not want to think about it like, did I make a silly mistake along the way? And you really can. And so one of the things I like to do is I like to go ahead and draw a coordinate plane and label it just to make sure we're good, because a lot of our numbers are going to be decimals. So remember that this is 0 and 2 pi right here, obviously, at the end. But that's 0 or 6.28 if we look at the decimals. And when we get that calculator out, especially on some of these ladder problems, that's when we actually need to remember we're good. The top, I should say, let's go ahead and do this one over here first. So we obviously know that this is going to be pi. Pi is a decimal point, 3.14. Halfway between that is 1.57. And then last but not least, we have our bottom one here, and that's going to be 4.71. So if you know what quadrant you're supposed to be in, because you're talking about all students take calculus, or a smart trig student, smart trig class, excuse me, then you have an idea of where you should be. So this is kind of one of those things where I would keep it in the back of your mind. And if you're doing all this math and you're like, I'm not sure if my answer makes sense, really look at the decimal and say, is it where it's supposed to be? Because if it's not, that's a good check. So this is also, again, this is really important for mapping when we look at those all solutions to make sure you're good to go. I'm really a fan of first looking at one thing, and that's, does it make a straight line? So if it makes a straight line, a straight linear line like this, then that's usually one that you can do, okay? The other one that we like to see is there some sort of symmetry? So if I go ahead and I draw this really quickly out, we can see that there is some sort of symmetry. And then make sure when you do your mapping that this distance, and this distance are all the exact same amount, because if one is pi over 6 and the other one is pi over 3, that is not going to match. They have to be the same all the way around for that to actually work. Okay, we see a lot of this with the 2 pi over 3. That's the one that we tend to forget. So definitely keep the mapping, excuse me, the picture aspect in your wheelhouse. So let's look at our first one here. So in our first one here, it's already in our nice factored form. So the reason why we get to do what we're going to do is we're going to use what's called the zero product rule. That says that if a times b is equal to 0, 0 is such a special number, the only way to get to that is that either a equals 0 or that b equals 0. And that's where a lot of our factoring comes into play. So in this case, we know that either our first parentheses is equal to 0 or that second parentheses is equal to 0 for it to actually be 0. So we're going to do cosecant x minus 1 is equal to 0, or we're going to have sine x plus 1 is equal to 0. One of those parentheses has to work. So this is cosecant x is equal to 1, and this is sine of x is equal to negative 1. So the back to basics rule says, hey, this is not a sine, cosine, or tangent. Not a huge fan of that. So if I were to think of this 1, it's the same thing as 1 over 1, where this is the hypo and this is the opposite. I can switch that to be sine, which would still be 1 over 1, but then my opposite would go on the top and my hypo would go on bottom. And so really I'm going to say the sine of what x is going to give us 1. Okay, so another thing really quickly I should have mentioned before is the kind of the idea of your wheelhouse. So the wheelhouse is what I call the unit circle. And so if your answer is either plus or minus 1 or 0, and then plus or minus 1/2, plus or minus 2 root 2, and then plus or minus 3 root 2, that's all of our unit circle. And so we should be able to do that without a calculator, and that's the kind of stuff that will be on the non-calc celebration of knowledge, aka test for those in other classes. But if you get some funky decimals, that's when you're going to need the calculator. Okay, so this is 1. We know that's in our wheelhouse. So when is sine 1? So just remember it goes cosine and then sine. So right here at 0, 1 is where sine is 1. So my answer is going to be pi over 2. Now, because that's the only answer, I'm going to pause right there, because if it's down here, it's 0, negative 1, not so helpful for this first part. Okay, so I like to write all my answers first and then worry about my mapping. So on the second one here, it's going to be, alrighty, it's already in my back to basics, it's already sine. So when is it negative 1? We sort of talked about that. That's 3 pi over 2. Excellent. Wonderful. So here we have our two answers. Now, the next question is draw a map, which we have right here, or our picture. Can I map one onto the other? So how do I go from this dot to this dot? Well, clearly that's pi. Is it congruent going the other way using my geometry? Absolutely. So that's my mapping. To go to here, we're going to use pi. So we're going to take the smallest one, so that's going to be pi over 2, and then we're going to say we're going to add pi k, because that's our mapping. And that's our all solutions right here, because remember, all is when it happens no matter what. And then these two right here are my solutions when it's in between 0 and 2 pi. And since it's asking for both of those, we've satisfied it. We're good to go. Alrighty. So, ladies and gents, already want to talk about this one. This is a cotangent squared. We talked about this with our trig strategy right here. So the first thing that I'm going to do is I'm going to say, okay, this is a lot going on. So what if I said for now, and you don't have to use this strategy, I'm just trying to help you out, give you something new. So what if u was the cotangent of x? Let's start with that concept. Well, this is cotangent squared, so this would be u squared. and this is cotangent, so that would just be a u. Okay, we can solve this. So I'm going to move u over because I need to factor it, which means it needs to set equal to 0 first. So 0 squared minus u. And then I'm going to say, what is my GCF? So my GCF here is a u. So then I'm going to get u and then u minus 1. Now, could you have done that over here? Absolutely. Cotangent squared minus cotangent is equal to 0. Factor out a cotangent, and I'm going to get cotangent minus 1. And then here is the same thing, because when I back substitute, I'm going to get cotangent and then cotangent minus 1. Cool. Done. Easy. So again, the u is just a strategy if you get stuck. But if you just want to go and tackle it, that's cool too. So now I'm going to take this cotangent part. That's going to be my first part. Cotangent of x is equal to 0. And then my second one will be this parentheses. So the cotangent of x minus 1 is equal to 0. So this right here, we're going to go ahead and say, alrighty. So this is cotangent. You can change that to tangent. So remember that this is really over 1. Okay. So that means I'm looking for my tangent, which is 1 over 0, or where is my tangent basically undefined. Okay, so we're going to go ahead and find that out in just a second. And then on this one, we're going to go ahead and say, all right, our cotangent of x is equal to 1. And so when is the cotangent 1? You could do that just like you could have done this part. If you know that off the top of your head, that's fine. I'm a back to basics kind of guy. Let's switch this over. So this is a 1 over 1, and this is going to be adjacent over opposite, because that's how the relationship would be. So tangent would be opposite over adjacent, so it's still just the tangent of 1. So I need to know when the tangent is undefined, and we know that from our unit circle at pi over 2 and 3 pi over 2, okay? And then we're going to go ahead and say, let's look over here. When is the tangent 1? That from our unit circle, still in our wheelhouse, is going to be at pi over 4 and then 5 pi over 4. Alrighty, so this is where I'm going to map it, and you can go ahead and do it in different colors. Sometimes that's helpful. So I'm going to do these ones right here in blue. So pi over 2 is right here, 3 pi over 2, and then I'll do these ones here at pi over 4, and then 5 pi over 4, which would be about right there. So if I look at it, if I try to go from here to, I'm sorry, I missed my dot there, from this dot to this dot to this dot to this dot and then back again, you could see that they're definitely not all the same, because if there's a mapping, all 4 of those need to be the same, in which case there's not. So let's go ahead and say, all right, there's not a way to do one entire equation, but if I look at my blue ones, clearly that's going to be pi again. As we mentioned, from here to here would be pi, and then it would be congruent on the other way. So we're going to go ahead and take our smallest one and say x is equal to pi over 2 plus pi k, and that makes sense because our period for tangent and cotangent is pi. And then over here, if I erase these blue ones, from here to here, and then the other way is also pi. So x is going to be pi over 4 plus pi k. Now, if you're using pi n, totally cool, because that was how our Math Excel kind of went down. But those are our 2 all solutions. And if they want all of our 0 and 2 pi solutions, that's going to be these ones. So just be careful, look at which ones they're asking for, and you're going to be good to go. All right. So, ladies and gents, this is one where you might try that substitution strategy again. So let's say u is equal to cosine x. If it's not jumping out the page at you right now, sorry, not squared, just cosine x. And so I'm like, okay, this is a cosine squared, so it's going to be 4u squared minus 1 is equal to 0. And then I'm like, oh, sweet, this is a perfect square. So this is going to be, square root of that is 2u. Square root of that is 1. It's got a minus in between. That's a dead giveaway. So 2u minus 1, 2u plus 1, because it's a perfect square. Don't forget to back substitute. So 2 cosine x minus 1 is equal to 0. and then 2 cosine x plus 1 is equal to 0. And now we're off to the races. Solving this should be pretty easy. If you want to wait till the end to back substitute, that works too. But I'm going to get 2 cosine of x is equal to 1. So cosine of x is going to be 1/2 on my first one. And then over here, we're going to get 2 cosine of x is equal to -1. And then cosine of x is equal to a -1/2. All right. So this is in my wheelhouse. All right. So I happen to know when this is. Okay. So the first thing we're going to do is know that this is obviously 1/2 going to be a √3 situation. Okay. So I go, all students take calculus or a smart trig class, and go, alrighty, so if it's cosine that's positive, that means it's going to be not these two quadrants. So I need my reference angle here. So that's going to be pi over 3. And then down hizzle, and that's going to be 4 pi over 3. All right, because we got to make sure that where our sine is, or sorry, cosine is positive. Now I'm going to do a second one over here. I'm going to bring that back in just a second, but just for the moment here. So this is negative, so all students take calculus, and this one's not going to be down here. So I need that same reference angle. So right here, that's going to be 2 pi over 3, and then 1 down here, and that's going to be, sorry, I put my, this is going to be our 4 pi over 3, and I screwed that up. This should be 5 pi over 3. Alrighty, apologize about that, but we got our 4 answers, and I didn't have to go too far before I made a mistake, so that's good news. Alrighty, so I have my 4 answers right here. We're all set to go. So let's put them on one graph just to see if there's any mapping that's going to happen. Okay, so if we take a look, there's this one, and then there's this one, and then there's this one, and then there's this one. So my first instinct is I'm like, cool, look, it goes, I'm sorry, had a little pen there. This is 1, 2, and then I'm like, okay, let's look at the pattern. So maybe it's just a pi over 3. There is a pi over 3, but then if I wanted another pi over 3, it would land me right here. So that's not going to work out for me. So we can't say it's just pi over 3. So we tried, it didn't work. Let's look if there's another one. It really doesn't. So what we're going to say is this is a straight line though right here. So we're at pi over 3 here. And then we can see that we're going to go pi over. So we're going to start with x is equal to pi over 3 plus pi k for my mapping. And then obviously on the other one, I'm going to use my 2 pi over 3. And that's going to land me right here. And then clearly over to here, that's also pi. So we're going to get 2 pi over 3 plus pi k. Alrighty, sorry about the mix up there with the 5, that's my bad, but at least we got it in the end, we didn't get too far. Alrighty, so ladies and gentlemen, boys and girls, here we have our first one where we have a double trig function. So we have all sines and all cosine, or so we have sines and cosines. I would just make sure that it's all sine, cosine, and tangent first. If you have a secant or a cosecant or a cotangent, get out of that first. This is a great example. I'm going to erase this so it's just very cluttered right now. This is a perfect example of a GCF, and in this case we have a GCF of sine x. So when you divide that out, I tell my freshmen that, like, hey, this is called Hart division. So sine over sine is going to be 1. And then when I go into this side right here, I'm going to go ahead and get a plus 2 cosine x. Because the sines, again, will cancel, and what we have left is the sine and the cosine. Well, your GCF still has to go in front, so don't just cancel it out. That's not how that rolls. So then we set it equal to 0. So we get sine of x is equal to 0, and then 1 plus 2 cosine of x is equal to 0. So solving this quickly, we're going to get 2 cosine of x is equal to -1, and then cosine of x is equal to a -1/2. All right, so we're set to go. Sorry, this is at 0. There we go. So we know when this happens, hopefully we're good on our unit circle. We're good with that at 0 and pi. So make sure we're good right there. That's going to be right here and right here, which makes sense because it's 0 and 1. All right, so -1/2. We just got done doing that, but just one more time, all students take calculus. This is negative, so it can't be in this quadrant, and it can't be in this quadrant. So if we go this way, that's going to be, excuse me, I was looking at this going, that's not right. So it can't be in this quadrant, and it can't be in this quadrant. There we go. This is why you should make videos at 8:40 at night, sports fans. Sometimes you're not as fresh, spry chicken. All right, so we're here, which is going to be 2 pi over 3, and then we're going to be down here, which is 4 pi over 3. Those are both negatives. It's supposed to be negative 2 pi over 3, 4 pi over 3. Here's all of our answers that we need. Boom, shakalaka. Okay, so let's do our mapping and see if I can't map one on the other. So I like to make one big coordinate plane. So we have 0 and pi, and then this one's going to be somewhere around here at pi over 3, and equally somewhere over here, pi over 4. So we can once again see that this distance right here and this distance right here, those are not the same. These are the same. These two are the same, but since they're all not the same, we got no mapping. So in this case, we do have 1 here, sports fans. So we do have 1 here, and I'm going to say, let's check this out. Let's forget this for just a second. Let's cross that out and pretend it doesn't exist. If I go starting here at 0, I can go to here, and then to here, and then to here, because that's going to be basically, this is 0, 2 pi over 3, so sometimes we need to see it in degrees, so 120 degrees. And then this is going to be another 120 degrees to get me to 4 pi over 3. And this will be 120 degrees to get me back to 360. Alrighty. So all those are the same. So let's start here. So I'm at 0, and then I'm going to go ahead and add 120 degrees, or 2 pi over 3k. And that's going to hit these points right here. And then the one we forgot about temporarily because it didn't quite hit the mix was that pi. So we're going to go ahead and say pi plus 2 pi k because it's got nobody else that it really maps with. Yes, it maps with this one over here, but we've already taken care of that with this first one, and we don't want to hit doubles. That's kind of the whole point of this, is we don't want any repeats. All right, so I'm going to erase this because I'm going to need that for this example number 6 here in just a second anyways. So let's mosey on over here to number 5. All right. So, ladies and gentlemen, boys and girls, this has got one of those other ones that's got a lot going on. So, and 2 trig functions. But notice the trend that everything's been pretty much set equal to 0. So let's bring this over. So I'm going to subtract a tan. And I would like to think that I could just subtract this. But since this has a sign, I can't just subtract those. Those are not like terms. It's like an x and a y. So I'm going to get tan squared sine minus tan squared equals 0. Then I notice the GCF. So in this case, I'm going to take out a tan squared because that's what they have in common. And so I'm going to get sine minus 1. That's a common mistake too, is when we do that, reducing that GCF, is we get this part. We get the sine because it's there, but then we'll forget on this aspect that tan squared over tan squared, or excuse me, tan squared over tan squared is 1. Alrighty, so then we're going to set those equal to 0. So we're going to get tan squared is equal to 0, and sine minus 1 is equal to 0. Well, when tangent squared is equal to 0, that's the same thing as tangent times tangent is equal to 0. So really, we're just saying, hey, when is the tangent equal to 0? Because it doesn't matter, because 0 squared is still 0. And we know that that's at 0 and pi. Unit circle coming in strong on this one. All right, moving on to this one over here, we're going to get sine is equal to 1. And so we know that that's going to happen at pi over 2. All righty, so we have our 3 answers if we need them. So we're good there, but let's do our mapping to see where we're at. So I have 0, I have pi, and then I have pi over 2. So I'm looking at this going, oh man, this could be another one of those situations. This to this is the same here. This is 90, this is 90, but this one right here, 180. So no dice there. Let's try to cancel out one of the points like what we did over there. What if we don't include this one? Well, that means that this is going to be 180. So those would be the same. So we're going to come back to this in just a second. So it's not like I canceled it out. I'm just not including it. So I started at 0. So this would be 0 plus pi k, because that's how I got there. I want 180 degrees or pi. And so then the only one left here in green, or I should say blue now, is that pi over 2. And since it doesn't map up with anybody that we haven't already counted, we're just going to say plus 2 pi k. Alrighty. Ladies and gentlemen, boys and girls, moving on to this next one. This is an example of when I could use my substitution again for my trinomial. So I'm going to go ahead, and if you don't need to, then don't have to, but u is equal to sine. So I'm going to get 2, I should say sine x, good grammar here. So 2 u squared minus u minus 1 is equal to 0. And since this is a trinomial, we're going to go ahead and do that x factoring. I don't have a problem with the x factoring. I like it. So 2 times negative 1 is going to be a negative 2. Add to a negative 1. So clearly those factors are going to be negative 2 and 1. So we'll get a 2u squared minus 2u plus 1u minus 1. Then we're going to go ahead and say, what do those have in common? Then the latter ones, what do those have in common? So this would be a 2u. This would be a 1. Make sure I did that correctly. Looks good. So we're going to go ahead and have 2u. I don't want to skip too many steps here. 2u, and then I'm going to have u minus 1, and then a 1, and then a u minus 1. These match, so we would factor that out. So I would get a 2u minus 1 from the fronts, u minus 1 because that's what they have in common. And then we say, hey, remember, u is sine squared. So you can plug that in here if you want to, or you can keep going. So I would get 2u minus 1 is equal to 0. So you could probably do this math in your head and get u is equal to 1/2. And then over on this side with this second parentheses here, you would go u minus 1 is equal to 0. So 1 is u 1. Well, remember, these aren't u's. I'm going to erase this. Should have erased it before so we have space. They are sine squared, or sines, excuse me. So we're saying 1 is the sine of x 1/2. And 1 is the sine of x 1. So unit circle game coming in strong. This is going to be pi over 2. And then this is going to be our, let's see, we have a, I think I did something wrong here. I'm going to pause here. Thank you, ladies and gentlemen, for the pause. We found out what I did wrong. This is a 2u, and then when I took that out, it's a u plus 1. So that's a plus, so that's a plus. And this is a minus, so this is going to be a negative 1/2. There we go. And then that's a 1. So I knew something was funky. We figured it out here. So because this is a 1/2, we know that's going to be a pi over 3. All students take calculus. So since it's negative, it can't be anywhere here up top. So it'd be down hizzy 7 pi over 6. And then down on this one, which would be 11 pi over 6. So I have 7 pi over 6. I have 11 pi over 6. And then pi over 2 as my solutions. So let's go ahead and plot them and see if there's some map in action we can do. Alrighty. So pi over 2, we can clearly see that that's going to be this one up here. And then this is going to be 7 pi over 6, about right there. This will be 11 pi over 6, which is right there. And it's making kind of that peace sign, so that's usually a giveaway that we're going to be able to get there. So from here to here, that's 120 degrees, 120 degrees, 120 degrees. So how do we write that? That's pi over 3. So what's our shortest one, or our smallest one? That's pi over 2. So we're going to take pi over 2 plus 2 pi over 3. And that's my mapping one. Cool. Easy peasy, lemon squeezy. So you can see how these strategies work and how they're helpful. Going back over here at the top, really trying to focus in on those. We've looked at the factoring, the substitution, the back to basics. The picture's been key, especially when we start getting in those decimals here. We're going to come back to these numbers of 1.57, 3.14, 4.71, and etc., because that's going to kind of help us out, and then we'll go to town. All right, so ladies and gentlemen, boys and girls, let's take a look at this one. So it's tangent. So when we go ahead and we do tangent, the first thing we're going to do is, because this is a calculator part, they're saying we're going to take the factoring out of this and just let's focus on where it's supposed to be. So all students take calculus. So this tan x, we're saying, all right, when is the tan going to be 3.8? That's how we want to think about this, our inverse trig function, knowing that it's going to be in this quadrant right here and this quadrant right there. All right, so we put that in the calculator, of course, making sure your calculator is in radian mode. So if you hit the mode button, it should be radians, as we can see. So I'll hit second tangent, and hopefully this will work out here. 3, if not, well, just, where's my decimal? There we go. Come on. I'm going to pause. Alrighty, calculator fixed here. So clearly you've seen how I put it in there. I hit tangent. So we got the 1.3. So we're going to say it's x is equal to 1.313. So clearly that's going to be in this quadrant right here. But we want to have that same reference angle theta right there. So if it's in this quadrant, this is going to be that same reference angle. So let's think of, how do I get there? Well, from here to here is obviously going to be pi, and then I need this x to continue on. So we can think of this as x and x. So this is one solution. The other solution is going to be the pi that I needed to go, or the 3.14, plus 1.313. And so this is going to say my second solution is 4.46. We'll say 463 and call it good. So here are our two ones. So again, that's why the picture is really helpful. And let's look at this. All right, so this is supposed to be 3.14, and this is 4.71. Is that in the correct decimal range for that quadrant? Yes, it is. Is this in the same decimal range as it needs to for that quadrant? Beautiful. That's why the picture is so key. Alrighty, so let's go ahead and throw this one in the calculator here, knowing that we're going to go ahead and have to use all students take calculus. So second cosine, and then we're going to do -1 divided by 7. Alrighty, so -1 divided by 7. So we're going to go ahead and notice that x is 1.714. And so it's supposed to be right here. Oh, excuse me. It's going to be right here because this is when cosine is negative. And then I'm also going to need it to be right here because that's where cosine is negative. And because, again, the negative's here, not the negative down here. It's all about what you started with. So that's why it shouldn't be in here or here. So let's think about this. This is 1.57. This is 3.14. Is that in the range it should be? It is. Check. But I need to go in this quadrant right here. So I need it to be at least bigger than 3.14. So we're going to go all the way to 3.14, add this to it. So x is going to be pi plus 1.714. So we'll call it 4.574. Now, as long as you're within 2 decimal places, you're good. But let's look at this. Remember, this bottom one here is 4.71. We are in where we need to be. Probably good then. So why don't you try number 9, make sure you're gravy on it, that it works out, and we'll see how you did. Alrighty, welcome. Hopefully you guys did it and you crushed it. The answers you should have gotten was 5.55 and 3.87. Let's take a gander at how that works. So this is sign is negative. So really quickly, all students take calculus. We are looking at all stuff down here. Okay, so let's see if your rules are strong, my friends. So we put in the calculator, you went inverse sine of -2 divided by 3, and you got x. Oh, that's not my pen here. X is equal to -0.7. Let's see exactly what that was. 297, so we'll just say 7.3. That's close enough for government work right there. So I know that that's this angle right here, which is wonderful and spectacular if we're going in the negative direction, but we really want this to be going all the way around. So really I want is, how do I get to there going in that way? So we're going to say, all right, let's add 2 pi to this to get it where it needs to be going in the right direction. As you can see, we're going in this direction, our standard direction, and that's going to give us 5.55. So that was the one solution. And remember, this is 6.28 and 4.71. Is that in the range it needs to be? Yes, it is. Check. And then let's go ahead and look at quadrant 3. So quadrant 3, if I can erase this right here and focus just on this one right here. All right, so to get to here, I need to go at least pi. So I need to know that my x is going to take at least a pi to get there. Then I need to go a little bit extra, so that's my theta. Now, notice if I add this negative, I'm going to go ahead and be back in my range over here, which is not where I want to be. Okay, so check that out. If we take and just say, all right, plus pi, we're at 2.41. This is 3.14, y'all. That's going to land us right here. That's not going to work. That's why the picture is key, and those kind of putting those decimals in there is super helpful. So now I know, hey, this is where I need to be. So that's going to be pi plus that 0.73, and that's going to give me 3.87, and that's going to land me where I need to be. Boom, shakalaka. We're good to go. Alrighty, last one but not least here. So last one here, ladies and gentlemen. Sorry, I had to edit the video there. That's what happens when you don't honor your negatives. You screw up the whole thing. So, ladies and gentlemen, let's try this and actually do it right this time, because that's always fun when you do it wrong. So, ladies and gentlemen, the first thing you notice is that it right here just says find the values. We don't have to find all values. So that's going to save us a little bit of heartache. But I'm going to right off the bat go, even if I didn't know this is the quadratic formula needed, I'm definitely going to say u is equal to sine x and get 4u squared minus 2u minus 1 is equal to 0. Now, I'm going to try and hope and pray that when I do 4 times -1 and I get a -4, that I can find numbers that add to a -2. And that's the bummers, is that if I do 4 and -1 or -4 and 1 to a -2, vice versa, none of those work. There's no factors. And that's when you have to do the quadratic formula. So again, this is our A term, our B term, our C term, X, or in this case I should say U, because we're doing U, is equal to -b plus or minus b squared minus 4ac all over 2a. Alrighty, so I'm going to go ahead and throw my b, which is the -2. Notice the sign is coming with in all those spots. Okay, so I'm going to have a negative of a -2 plus or minus, and I'm going to do -2 squared. And if I look at my A is going to be this 4 here, and it's going to go in 2 spots. So we're going to go ahead and say minus 4 times a, which is 4. All that over times 2 times 4. And then last but not least times my c. And my c is a negative 1. Just that 1 right there. And the square root of all that. So whenever you're doing the quadratic formula, you know this, but you have to do all your radicals first. So if we take a look at this, we're going to have a negative and a negative is going to make this a positive 2. So positive 2. We'll just write just 2. Plus or minus 4. And then if I look at this, negative 4 times 4 is 16. Negative 16. Minus 1 is going to give me a plus 16 all over 8. So we still got to do inside that radical first. And that's going to give me 2 plus or minus root 20 divided by 8. And then we'll have to do our factor tree for 20. And hopefully you guys can do this in your head. But if not, we can see that this is going to become 2 root 5 over 2. Then we're like, cool, all these, over 8. There we go. All these outside numbers, 2, 2, and 8, are all divisible by 2. So we're going to get head 1 plus or minus 1 root 5 over 4. So basically, we're going to be left with u is equal to 1 plus root 5 all over 4. Plus or minus. So again, with the plus or minus, 1 is going to be a plus and 1 is going to be a minus. Lord have mercy. So let's bring our sign in. So remember, u was sine x. So u is equal to sine x. So we're going to say the sine of x is equal to 1 plus or minus root 5 over 4. So let's find out what that decimal is, because we're going to need to do definitely some calculator. So we'll do 1 plus root 5 over 4 and 1 minus root 5 over 4. All righty. So go ahead and hit the calculator button here. So if you go ahead and you hit this alpha and then y equals, it's going to bring up this if your calculator is nice and updated. And you can say, hey, I want to make a fraction. So we go 1 plus the square root of 5 divided by 4. Well, don't need that extra negative in there. And we'll go 0.81. We'll make the rounding super easy with this. And then I'm going to hit second entry, and then I'm going to go back and change. If you hit the arrow keys, you can go back and change this to a negative. And then that's going to be, we'll say 3.1. All righty. So now as it stands, we finally are where we're at. Okay. I'm going to have one where the sine of x is equal to 0.81. And I have one where the sine of x is going to be negative 0.31. Okay. Good to know, my friends. So, ladies and gentlemen, do I have my signs right here? Looks good. Alrighty, so I'm going to go ahead and do our calculator here. So we're going to say the inverse sine of 0.81, find out where we're at. Inverse sine 0.81. Let's go with the 0.90 just because we can. And so we're going to get x is equal to 0.942. So we'll just say 94. Pretty good. So let's go ahead and take a look at where we're at. So remember, it's all students take calculus. So my reference angle here is going to be that x, but I need that same x over here. So this one is going to be in quadrant 1, but then I need to be in quadrant 2. So I'm going to go ahead and say, well, if this is pi, I want it to be a little bit less than that. So x is going to be pi minus 0.94 to give me my other one. So we'll do pi minus my answer, and then we get 2.19. Alrighty, so ladies and gentlemen, boys and girls, let's go ahead and go to our other one here. So this one's negative, so we know it's going to be a little bit janky, but we can roll with it. So all students take calculus. So we're going to want to be down here. It's going to give us a negative, so we know that we're going to have to add it to 360 degrees, or excuse me, it's 2 pi, but we're going to get point. So I need my negative in there. Come on, 309. And so I'm going to get x is equal to negative 0.314. If that looks about right. Okay. So remember, that's this angle down here, but I'm going the wrong direction right that way. So I need to go all the way around here. So I'm going to say 2 pi plus that 0.314. And because it's negative, we're going to hit right where we need to be. So plus 2 pi. And I'm going to get 5.96. Alrighty, and so we have it right here. But remember, we need that same reference angle. If I erase this over here, we'll do this in orange. So I need this x. So I need a pi, because I'm going to go all the way to here. And then that little extra that we have that we've called x. So in our next one, we're going to say x is equal to 0.314. We know it's negative. Like, we can see that right up here. That's fine. But we know that that's a reference angle, so we can make it positive and add and subtract. And then plus pi. So we're going to go ahead and, nope, that's not pi. Pi plus 0.314, and we're going to get 3.45, which is bigger than our pi of 3.14, so we're good. So in this case, we have 4 answers: 1, 2, 3, and 4. So I know that this was a long video, but I hopefully found it okay. If you took your time getting through everything, hopefully this makes sense. If you went faster, you're good to go. We will catch you next time. Take care, sports fans.